Welcome to This Explainer. Today, we're taking on a massive, singular creative challenge, bringing a highly realistic grasshopper to life using three wildly different artistic mediums. Whether we're talking about generating digital pixels, meticulously staging photographs, or molding textured polymer clay, recreating believable insect animation is literally one of the toughest tests of any creator's skill. We're going to dive right in and explore exactly how to pull this off and truly master the mechanics of movement.
Here's our creative roadmap for today. We'll start with the Great Grasshopper Challenge, then look at generating AI insect movement, stop-motion physics and timing, crafting a practical puppet, advanced animatronics and modeling, and finally, choosing your animation path. Let's get to it.
Part 1. The Great Grasshopper Challenge. Setting the stage.
To start, we really need to establish the sheer complexity of our core variable here, an insect character. I mean, when you're dealing with a creature this tiny, the basic rules of animation shift dramatically. Put yourself in the director's chair for a second and ask yourself, how do you actually capture the lightning-fast movement, the physical weight, and all those crazy micro details of an insect? It's tough. An insect's erratic physics, the sudden acceleration of a jump, or the way the light catches a translucent wing, are incredibly difficult to recreate convincingly. Why? Because your margin for error is practically zero. Just one wrong frame and suddenly it looks like a glitchy alien instead of a bug. You literally have to manufacture absolute realism from the ground up.
Moving on to Part 2, generating AI insect movement, the digital solution. In our source material, analysts ran this fascinating, highly specific Cyber-B test across over 50 different AI video models. They wanted to see which algorithms could actually handle fast-moving insect physics without the whole image just breaking apart. Well, we're going to take those exact lessons and apply them to our grasshopper. To command our digital creature, we need a precise text-to-video prompt. Using the workflow from the Runway Gen 4.5 guide, we break our prompt down into a superstructured formula. Step 1 is your subject, an emerald green grasshopper. Step 2, the action, leaps in slow motion. Step 3 is your camera, a tilted macro angle. And Step 4 is style, cinematic lighting and motion blur. This structure matters immensely. Structuring your prompt with positive phrasing, telling the AI exactly what you do want rather than what you don't want, gives the engine a crystal clear visual blueprint. You're establishing the environment, the physics, and the lens all in one single breath.
Now here's where it gets really interesting. Look at the contrast between these top video models. There's honestly no single best tool out there. It completely depends on your shot. Based on the testing data, Kling 3.0 handles high motion physics the best. It inherently understands mass and momentum, meaning it'll naturally calculate the recoil and wind effects of our grasshopper's jump. On the flip side, Runway Gen 4.5 is the undisputed king for camera control. So if you need a cinematic, tilted, macro tracking shot flying through the air alongside the bug, that's your engine. And if you're building out a whole sequence and you need to cut multiple angles together without the insect randomly changing its shape between shots, Pixverse V6 is your go-to for multi-shot consistency. You just pick the tool that fits the physics of your specific scene. So, AI is obviously incredibly powerful for generating visuals in a matter of seconds. But what if you want to build it for real, with your own two hands? What if you want to physically interact with the materials, feel the weight of the character, and shape the movement yourself? Which brings us to Part 3, stop-motion physics and timing, the tactile realm. Here, we step completely away from software algorithms and move into the physical world, applying animation principles frame by frame with a camera and a tangible model. As highlighted in the stop-motion analysis from our sources, the absolute most important element for giving any action believable weight is ease in and ease out. This is the secret sauce for avoiding that stiff, robotic movement. Mimicking organic muscle tension requires serious planning. By grouping your photographs tightly together, making just microscopic adjustments to the puppet at the very start and the very end of the grasshopper's leap, and then taking much larger physical jumps with the model in those middle frames, you create this incredible illusion of powerful organic weight. The movement accelerates and decelerates exactly like real biological muscles do when they tense up, fire, and eventually relax.
This really highlights a stark difference between the mediums, digital AI recoil versus physical stop-motion recoil. A model like Kling AI, it automatically calculates how a body reacts when landing because it's pulling from millions of hours of training data. But in stop motion, you literally have to honor Newton's laws manually. For every action, there's an equal and opposite reaction, right? So when your grasshopper puppet hits the ground, you, the animator, have to manually pose that puppet bouncing upward slightly. You have to physically simulate that organic recoil and the dissipation of kinetic energy over 3 or 4 frames before the bug falls completely still. If you don't do that, the landing will feel artificially stiff and totally unbelievable.
All right, part 4, crafting a practical puppet, building the beast.
Of course, to animate a physical grasshopper, we've got to build the thing first. And this is where your materials essentially become your storytelling tools. Choosing the right physical materials is what lets a model perform movements way beyond a standard figure's range of motion. Drawing from practical VFX modeling sources, we start with a wire armature. This gives us a durable, posable skeleton. Next, we coat that skeleton in polymer clay so we can sculpt a really detailed, textured outer shell. Now for the rigid anatomical parts, like those powerful back legs, softwood is actually perfect. It's lightweight and super easy to sand down to get those sharp insect-like angles. And here's an absolute pro tip from veteran stop-motion animators: use custom sticky tack joints. Seriously, instead of using rigid ball and socket metal joints, using a strong adhesive tack allows you to literally pop the limbs right out of their normal sockets to extend the character's range of motion horizontally. It's a real game changer that gives you the flexibility to achieve incredibly dynamic, realistic leaps on camera without snapping your puppet in half.
And when you film that practical clay model on a miniature set, say a kitchen counter, it creates instant tangibility. Scaling the physical environment down so the clay creature interacts with real-world objects, like the edge of a counter or a textured ceramic plate, makes it feel so grounded and present. It basically forces the viewer's brain to accept this giant insect because it exists in a real physical space. You're capturing actual lighting, natural lens blur, and true shadows bouncing off the set in a way that you just can't easily fake inside a computer.
Next up, Part 5, Advanced Animatronics and Modeling, Scaling Up.
But hey, what happens when stop motion isn't quite right for the shot? What if we need super fluid, real-time movement for an extreme macro close-up? That's when we level up to animatronics, the art of bringing wire and clay to life using hidden cables and electronic skeleton rigs. Say our script calls for a tight, high-definition shot of the grasshopper's antenna twitching organically in the wind. Moving that frame by hand might actually look way too jittery. Instead, we wire the model with internal mechanics, which allows puppeteers standing just out of frame to control those micro-movements live on set. The camera just rolls continuously, capturing this beautifully smooth, uninterrupted biological realism.
Now, here is where the physical and digital worlds eventually merge in the most spectacular way. The source material on VFX modeling reveals this stunning production secret. Quote, "We produce models of some creatures up to 2 meters to capture the finest details." Just pause and imagine that for a second. Standing next to a grasshopper the size of a human being, literally 2 meters long, just so a digital scanner can capture every single microscopic ridge of its shell. Sometimes, to get the absolute perfect digital 3D model for computer graphics, artists literally have to sculpt a massive, oversized physical monster. By scaling the prop up that huge, they ensure the scanner captures a level of microscopic texture that simply wouldn't be possible to model by hand on a screen. It is an incredible merging of physical craftsmanship and cutting-edge digital technology.
Finally, Part 6, Choosing Your Animation Path, the Core Truth.
So we've looked at crafting detailed text-to-video AI prompts, wrestling with tactile stop-motion physics, building custom practical puppets, and even scaling up to massive animatronics. And all of this leads us to the ultimate takeaway from our explainer today. The medium, it honestly doesn't matter. The core principles of physics, timing, and storytelling remain the exact same. Whether you're typing a highly structured prompt into Pixverse, sculpting intricate ridges into polymer clay, or gently nudging a wire armature a single millimeter at a time, you, as the creator, must always understand the mechanics of movement. You have to intimately understand ease in, recoil, camera angles, and weight to tell a compelling story on screen. The tools will always change, but the artist's eye for reality, that does not.
You now have the foundational knowledge and the roadmap right in front of you. You understand the different tools at your disposal, from digital AI generation to tactile clay and animatronics, and you've seen exactly what it takes to make it all happen. So, the only question left for you is which medium are you going to choose to bring your very first creature to life?